Welcome everyone. So this is the new tutorial about generative AI and RAG based system. So if you are very much new about this concept, don't worry about it. Follow this. I am just talking about generative and RAG based system from scratch. Okay. So let's start our journey. So what is generative AI? So before going to the formal definition of generative AI, let's take an example of a newborn baby, right? When newborn baby come to this world, they know nothing, right? They are completely blank at that time. So how they learn? They learn from their surroundings, they learn from their parents, then they absorb words, right? And then with the help of those words, they show their creativity, right? If you consider any area, right? If someone is starting to play a cricket, they don't know anything about the cricket, but slowly when they play cricket, when they go to the pitch and when they start playing cricket, then slowly they create variety of shots, right? Because they learn with the experience, right? With the other bowlers, with the other batsmen, with the other fielders, with their coaches, right? So that's how exactly generative AI also learn and works, right? So consider a generative AI is something which is trained based on the large set of data to create something new. Now, what they can create, right? They can create images, they can create videos, they can create audios, right? So, whatever we have trained that particular model, that particular thing, then they create something new out of it, right? So when we are saying, okay, we are training something, we are training based on some data. So what we are training? We are training two models, right? So if you have heard about models, there are variety of model present in this generative AI space, right? So those models are actually a large language model. Why they are large language model? Because they have trained on large amount of data, variety of data to generate something, right? So some models are specific to generate images, some models are specific to generate text, some models are generate specific to audios, and some models are also trained based on to generate all these three things, right? So this is something called a large language model. And this is how exactly generative AI works. So if you consider what is generative AI, the formal definition is a generative AI is a type of artificial intelligence that can generate new content such as text, images, audio, even code based on the pattern they have learned, right? So if you take an example of GitHub Copilot, right, this is one of the example of generative AI. If you consider an example of Chat GPT, if you consider an example of something like with if you give us something input and it can give an audio, video, whatever, right? So right now every website, every company are integrating generative AI because generative AI has a large capabilities, right? So after moving forward, after what is generative AI, let's see how it works, right? So how generative AI works? As I told you, the first step that generative AI, it trains on the large data set, right? So the AI model that is trained on vast amount of the images and other data to understand the patterns, context and structures. So this is the first step that we train the model, right? The second thing, what it do? It understands the user's prompt. So what is prompt? Like the input that we are giving to the generative AI models, right? For an example, if I train the model based on suppose this is snowman, and I told the model that, hey, this pic is of the snowman and this pic is of the gift. So now model knows about it. Okay, whenever I have to generate something like a snowman, I have a reference image which is here, and if I generate the gift also, I have a reference image of this gift also, right? So whenever user give any prompt, suppose can you generate the snowman or can you create the gift box? So what generative AI do, what those model do, they create a new content. right? So because we already know, we already trained our model that this is the snowman image. So if you see on the slide number 3, this is the red circle is something we have trained on, and generative AI knows, okay, this is the snowman. Now if we ask to generate a new snowman, you can see that how generative AI is generating a new snowman or a new gift box in a green color, right? So this is how generative AI works. This is what it do, right? Now, once you understand how generative AI works, so let's move further. Okay, let's see some example of generative AI in real world, right? So first example I would like to take example of ChatGPT, right? So ChatGPT is a great example of generative AI. So suppose this ChatGPT model, which is using, right, GPT-4 or whatever, right? If I say to ChatGPT, can you create an essay, or if I say write an essay on generative AI, let's say, right? Now, because this chat GPT, this model knows how to write what is generative AI and all, so it can easily write an essay on generative AI. So if you type and enter, see, he is writing a essay, right? Chat GPT can write a nice essay, right? Because it is trained based on generative AI data set also, right? Because it knows what is generative AI, right? Now Chat GPT can show its creativity to create a good essay for us, right? And you can see that how quickly Chat GPT is writing that, right? Now, take a second example, right? Now, if I go to any website, so suppose if I say generative AI based websites, right? Now you can see, right? This is ask AI to build an app. So this particular website can create a app, right? Because it is trained based on the different coding things, based on the different areas of coding or language, and it can create an app for you, right? So this is how generative AI works, right? But actually there is a problem also, right? So if you see, chat gpt or any kind of a model can create something only to on which they have trained on, right, the data set, right? Suppose if they don't have any idea about, like, the question that I am asking, right, is specific to my domain, is specific to my company, then they don't have any idea about it, right? Then how they can generate the answer out of it? So for an example, if I again go back to the same prompt, right, to the same input, and I say what are the, or how many earned leaves, right? So how many earned leaves my company provides. So if I give this input, now remember, this particular question is specific to my company, right? And ChatGPT does not have any information what is my company. So it does not have any information about the earned leave also, right? Because I have never trained ChatGPT model on this data set. Now if I hit enter, see what ChatGPT will reply. So the chat GPT is replying a pretty general answer, right? Say that depends on your company. Now that depends on my company means this is not the exact answer that I was supposed to get, right? I should get the exact answer about my company. And this is pretty straightforward also, right? Because model has not been trained on the data set of my company, then the model cannot answer that, right? So that exactly, if you go to the slide, that exactly, what if I ask the question to my company, specific to my company, then this traditional AI models cannot answer that, right? Because the information can be outdated. The information is, relying on the training data, and model has not been trained earlier on this training data. So what is the solution? So model cannot answer that. So what is the solution? Like, why we need it, right? Why we need something else, right? So because model cannot answer that, so it can assume something which is wrong, right? So they can assume something pretty general, which we just see that when we talk about the earned leaves, right? They are not ideal for domains like healthcare, law, and finance. You can assume that because every country's law is different, right? Finance laws are different. Healthcare is specific to the diseases, right? So these domain or these companies, right, they need something which can be trained specific to their data set, and they then answer the question, right? Not cost effective and the handling the large data. So what is the solution of that, right? So we know the problem, we know what is generative AI, we know that what are the large language model, they are trained on the a large data set, but we know the problem with them also, right? And the problem is they are not able to understand my query which is specific to my need, which is specific to my domain. So is there any solution of that? Suppose you want to onboard generative AI in your company, right? And suppose a HR policy based chatbot you want to implement. Now that particular chatbot needs to answer your company's policies instead of answering other things, right? So suppose if I ask how many earned leave that my company provides, so it should answer straight to me that okay, 14 earned leaves or a 20 earned leaves your company provides, right? And what are the leaves, like what are the sick leaves they provide and other things, right? So is there any solution of it? So what is the solution? So let's talk about it, right? The solution is RAG based system. Okay, so what is RAG based system? So consider the RAG based system is, instead of relying or remember the LLM normal LLM thing, RAG searches for the latest or most relevant information before answering, right? It's like a student who, instead of answering a tough question from its memory, it refers to a notebook, right? What do we mean by that, right? So suppose if I ask a question, hey, how many earned leaves my company provides? So instead of going to my past memory or my trained memory, what I will do is I will go to the company policy document, I will search that document, and I will figure it out what are the leaves my company provide, and then those particular leaves as an answer I will return, right? So I am not directly given answer or any assumption. Instead, I am referring some external documents or external data. It can be anything to answer the user's query, right? So let's see in real world. If you have seen, I have uploaded a question here like how many earned leave my company provides, and ChatGPT does not have any answer, any correct answer of it, right? But what if I provide ChatGPT to some document so that ChatGPT can refer and it can give you an answer, right? So I have downloaded one document here. So if you see the download history here, so I have added a one document which is a leave policy document, right? So what I am going to do is I am going to give this document to ChatGPT, and I am telling ChatGPT, refer this document to answer questions on company policy, right? So now as soon as I give this, ChatGPT reads this document, right? And after that, it gives you an answer. Like according to your leave policy, the earned leave privilege is as follow, right? And it gives you an exact answer. Before, it was not able to give you a correct answer, right? But now ChatGPT is trained or is referring to this external document, then it can give you an exact answer. And you can see like how many like details also it is providing you. Now if you want to just cross verify like if the answer is correct or not, you can open that document. So if I open that document and if I go down to the leave policy here, so you can see like there is a national and festive holiday, and there is 20 work days in a year is a privilege leave. So if you go to the generative AI answer, it says to 21 working days per year, right? It's a nice format here it is giving. So eligibility and the other things that it is providing you, right? So this is how the ChatGPT is referring to the external document, right? Here also in the RAG based system, exactly we are doing the same, right? So we are referring to the external document, right? So I have given example like how many earned leaves my company provides. So chat gpt is answering, or any model which you are referring to is answering like, I do not have any specific answer to your company, let me check information is there in external data that I can refer to, and then it refers the company document that I have provided. Now once I provided the company document as I mentioned in the chat gpt demo, then it gives you an answer that okay, I have a turn earned leave or a 21 earned leave, right? So this is how the RAG model works, right? So let's go to the next slide. So I mean, this is exactly, it's searching the document, right? So the natural question that comes to our mind is, what if we take the content of the document, copy that document and provide the content of the document directly to chat gpt, and then creates a question and asks the question, does it answer that? So the answer is no, right? You should not do that. Consider a PDF which is like a 1000 page or a 2000 page, right? And if you copy and paste the whole content and give it to the any model and just ask a specific question, the model has some token limit, right? It will give you that okay, whatever the content you are trying to paste on the model or you are trying to give to the model is so long, right? And they cannot digest that. And it is this is also like right also, right? I mean, how can you give a 1 GB of data directly to the model as a and just ask the question, right? It's not a right way, right? So actually model has the token limit, so you cannot do that, right? If you do that, it occurs the more cost. Why? For an example, if I ask a question, how many earned leaves that I have, right? And I give the whole document content, right? On the next time, if I have to ask how many holidays I have, right? Or how many national holidays I have, then I have to provide the content again to the chat GPT, right? So because these model work and charge you based on tokens they generate and the tokens you give to them, then the higher text you are providing, a long text that you are providing, it will occur the more cost to you, right? And also there will be a performance issues because you are providing the large content, you are providing the long content. Every time model has to think about it, they have to traverse about it, right? And then they can only give you an answer, right? So because of these three reasons, we should not directly give the whole content to the model to ask any question. So let's see this in the real example. Okay, consider this particular text, right? So this is the some company policy document that I have actually copied from the internet and I have pasted into the chat GPT, right? For a reason, when I'm saying the chat GPT, you can consider any type of a model, okay? So if I hit enter here, right? So you are seeing that the message that we are submitting is too long, right? So see, ideally we should not do this, because if we provide this type of a large content again and again, this will occur as too many tokens and it will occur too much cost, right? So we should ideally avoid it. So what is the solution? Because the policies document or a company document or any kind of a document that we are trying to refer can be a large document, right? So how should we actually ask the question about that particular document to the models, right? So let's see that. So here is the another idea. So the idea is divide the document into the chunks, right? So this is the process that actually RAG follows, right? So what we do is we divide the document, a large document, into the smaller documents, into the smaller chunk. So for an example, if I have a document of let's say 1000 word, then we divide that document into 20 words or a 30 words, right? It depends on how you want to chunk your data, right? The next thing is we store those chunks in a more efficient way, right? That we call embeddings, right? So we will see this in greater details in the next slide, but just at the high level, just consider instead of uploading the full document, what we do is once we upload the document, we divide the document into the smaller chunks, right, before sending to the chat GPT or before sending to any model, because we are not trying to send the full document to the model. So what we do is, before sending the document to the model, we divide the document into the smaller chunk. We store those smaller chunk into the efficient way, right? And when the user asks those questions, then we get the most relevant chunk from the document that we have divided, and then the only those chunk we will send with along with the user question to our LLM or a model, right? So let's see this in the greater detail. Consider an example of this. Okay, this is a step one. So what we do, right, we have this large document on the left side, right, so which is explaining about the RAG based model, right? Now what we do is we divide this document into the smaller chunk. On the right side you can see that we have divided the large document which is on the left side into the smaller chunk which is on the right side. For an example, the first 5 lines on the right side, the next on the right side, right? So we have divided this whole big document into the smaller chunk. Before sending to the LLM, we are doing this process, right? Because the ultimate problem is why we are doing this, because we cannot send the whole left document to the LLM, right? So that's why we are doing some sort of kind of a pre-processing or some sort of things that can optimize the LLM performance, right? So the step one is we take the full document, we divide the document into the smaller chunk. Okay, the next step is, which is step two, these smaller chunks that we just divided into the step one, there is something called embeddings, right? So there are many embeddings algorithm. I will tell you like what are the embeddings, but consider the embeddings. There are many embeddings algorithm. What they are doing is they are taking those chunks which we divided on the left side, we are giving those chunks to the embedding algorithms, and they are creating the embeddings out of it, right? And each embeddings is not only storing the data of the chunks in a different format, but it is also storing what is the summary of that chunk. For an example, if the left side, which is saying retrieval augmented generation is a technique that enables something, right? So it embedding algorithm actually sense that it stores the summary of what this chunk is talking about. Okay, the same thing is on the second side, the second and the third. So each chunk, what is the chunk talking about, that embedding algorithm is storing that, right? Let's go to the third one. So what are the embeddings and how it is stored? So if you see, like when I'm saying that summary of chunk they are storing, they are actually storing in form of the numbers, and these numbers are anywhere between -1 to 1. So when we give this chunk to the embedding algorithm is creating some sort of numbers between -1 to 1, where each number here you can see 0.84 -0.64 or zero point 0.9. Each number is representing something, right? Maybe the first number is representing the summary about what is RAG. Maybe 0.75 is representative about the what is generative AI. It depends like how the what embedding algorithms you have used, but under the hood these embeddings are actually the numbers which is actually storing the summary of each chunk, what each chunk is talking about, right? So the third step, when we give the chunks to the embedding algorithm, it creates the embedding like this in the form of numbers, right? Now these form of numbers, they have to store somewhere, right? So as you are aware about, there are some SQL databases which stores the plain text or data, right? Now for storing these particular numbers like 0.83, which is between -1 to 1, there is a special type of a database that is available in the market, right? And many companies, there are many companies which are providing the database to store the embeddings. So those databases are called vector databases, right? Because they are storing these numbers into this database, right? Why there is a special type of database for these embeddings? Because when we fetch those embeddings from the database, it should be fast and efficient, right? So there is a special type of database that is designed, right, which is called a vector database, Okay, so just to recap one more time, what we have done, we have a large document. We divide that large document into the smaller chunk. Once we divide the document into the smaller chunk, we send that document to the embedding algorithms. Now, embedding algorithm is taking that smaller chunks and converting into the embeddings. Now, each embedding represent what each chunk is talking about, right? And those embeddings are stored into the vector database. So this is the step 3. Now, if it go to the step 4, right? Now, when the user asks a question, what is RAG, right? So what will happen? Because we already have a large document which is converted into the embeddings and stored in the vector database, which you can see here, right? Which I am just circling, right? Now, when the user asks the question, what is RAG? What will happen? We will again take the same embedding algorithm which we used to take to store the document which was talking about RAG, right, into the vector database. We will take the same embedding algorithm. We will convert what is the question, what user is asking, to the embeddings, right? So suppose user asks a question, what is RAG? We convert that particular question with the help of the embedding algorithms, and we give to the embedding algorithms, and it generates the embeddings, right, for that particular question what user is asking. Suppose it generates the embedding like minus 0.5, 0.8, 0.09, right? So what will be the next step is this question which is converted to embeddings. Now this embeddings will be matched with the help of the similarity search. So there are many algorithms just to figure out like what this embedding matches and perfectly matching to the what embeddings we have stored. So one is a similarity search. So what it will do is it will take this embedding and it will search in the vector database for the relevant embeddings, right? And suppose, I mean, it will not exactly match like 0.5, 0.8, 0.09 here, right? Just consider like there are many embeddings stored, and because of the algorithm that we are using to fetch it from the vector database, right, the algorithm that we are using, it will find the most relevant embedding, right? So suppose for this particular embedding, the most relevant embedding is the first one, right? So what will happen? The response from the DB will come like this, like 0.84, 0.75, minus 6.4, right? And remember, what is this? This is the chunk information which was talking about the specific thing. And based on the question I asked, what is RAG? Vector database and the similarity search decided that, okay, for this particular question, when you generate the embedding, the most relevant embedding that I am finding from all of this is the first one, right? So it gives you, okay, this is the embedding that you can refer, or this can be the smaller chunk where your answer is, right? So let's go to the next one. Once we get the embedding, right, once we get the embedding, which is this one, which we receive from the step 4, here is a step 4, right? And it is this particular text, right? You remember, right? This is the particular chunk for which that embedding comes, right? So suppose if you go here, the first embedding actually belongs to this particular chunk, right? Now the next step, what is happening? There is a question of user, which is what is RAG. Now we are adding this question, what is RAG, with the chunk which received from the earlier step, and we are concate those two particular question and the chunk received, and then we are sending to the LLM, right? So previously, why we are doing all this? Because previously we were not doing the chunking, we are not finding the correct embeddings. Previously what we were doing is we are sending the whole document to the LLM. But right now what is the difference? We are not sending the whole document to the LLM, but we are sending the most relevant document that may contain the answer to the LLM, right? So what will happen? We will take the question, we will take the chunk. Sometimes this chunk is also called context, right? So we will take this question, whatever the user asked, we will take the context or the chunk, and we send it to the LLM, right? And when we send to the LLM will take this content, take this question and analyze this thing, right? And it give you an answer. what it will give you? It will give you that, okay, RAG is the technique that enable whatever the question you have asked, it will search in this document and it will give you an answer, right? So this is the whole step. Now what will happen? See, if you see this step, which is step number 4, why RAG is called retrieval augmented generation. So if you see the step number 4, when we are converting the user question to the embeddings, and when this embedding is searching into the vector database and retrieving the correct embedding, this process is called retrieval. So the R which you are seeing in the RAG is actually the retrieval. And why this what this R is? This because of this retrieval process, right? Because we are finding the correct embedding from the vector database. Now in the next step, when we find the correct step with the correct chunk, and when we send this user's question along with that chunk to the LLM, that process is called augmented. So augmented means the user's question and the correct context, whatever we have give to the LLM, is called augmented. So in the second A, right, in the RAG, the A belongs to the augmentation. So this is actually the augmentation is. Now when we send this augmented input to the LLM, what happened? LLM analyzed that, it generates the answer for you, right? So that's why the last G, which is in the RAG, the G stands for the generation. So generating the correct answer out of this, right? So this is the whole step, right? So that's why the RAG is called retrieval augmented generation. So I think this is clear. Just to summarize again, why we need this? Because we tell, okay, if we want to get any answer, we cannot simply give it to the LLM, because LLM has their own token limit, right? And due to the performance and cost issue, we cannot give everything to the LLM again and again to get the answer, right? So what we are doing is, we are taking the whole document which is on the left side, we are chunking that document into the smaller document, right? Then those smaller document, we are giving to the embedding algorithm, and the embedding algorithm is creating the summary of each chunk in the form of the numbers, right, which you are seeing here, right? And those embeddings we are storing into the vector database. Once it is stored to the vector database, and remember this 1, 2 and 3, this step which you are here, right, the first step, the second step and this third step, this is called data ingestion, and this is a one-time process, right? So we don't have to repeat that process again and again. What we have to repeat is, whenever user ask any question, we convert the user's question again to the embedding, and that embedding we actually take and get the answer or get the equivalent or a relevant embedding from the vector database, which we call a retrieval process. And once we get it, we take that embedding and the user question and send it to the LLM. Now LLM does not have the whole document, but it has only the chunk that has the relevant answer, right? And this process is called augmentation. And once we get that input, then LLM will generate the answer accordingly based on the chunk and the user question we have provided here, right? And it generates the answer. So this is called generation. So that's why it is called retrieval augmented generation. So I hope this is clear to all of you, like what is the generative AI, why we need RAG, right? And why we can't send the whole document or a whole data to the models, right? So this is all about RAG. In the next tutorial, the steps that we have performed here, all these 5 steps, we will try to automate these steps, right? And there is a way to automate this step with the help of LangChain. So if you see a LangChain here, right? So LangChain, if you type a LangChain here, so LangChain is actually a tool or a library, you can say, which provides the way to automate these steps, right? So this is a framework which actually provides you to automate these steps, the first, second, third, fourth step. So if you want to chunk the data, or if you want to store into the embeddings, and if you want to retrieve from the embeddings, so all these 4 step or 5 step, LangChain is the framework which is providing you libraries so that you can automate this process, right? And also there is something called AWS Bedrock and knowledge base, right? So AWS knowledge base also is providing you to automatically, knowledge base is automatically taking care of all these four steps, so you don't have to worry about when you are using the knowledge base. So we will see those two things in the later tutorial. First we will talk about these automation with the help of LangChain, and then we will talk about the automation with the help of the knowledge base, right? And we will create a simple chat bot which can take which can be trained on the specific company's document, whatever it is, right, you want to train on, and then answer the user's question. So I hope it is clear what is generative AI, what is RAG. Please follow and like, right? And let's see in the next tutorial. Thank you.